Okay, today in class we talked about evaporation. As we're talking about water in the air, we need to talk about how water gets into the air. One of the ways that water gets into the air is through evaporation, and what we're looking at here with the lab is a damp cloth wrapped around a rubber with a rubber band around a thermometer, and we can see that it's starting off very, very close to 20 degrees Celsius. As evaporation is going to take place to change liquid water into water vapor, we're going to have to get that energy to transfer into the water, and that energy is going to transfer in from the air around it and the atmosphere, and that's going to cause the temperature to go down because energy is going to transfer away from things like the thermometer, the air around it, to the cloth itself, drying that liquid out. Like we talked about in class, drying your hands off with water on it. It feels cold. So as we look at the temperature, it's already gone down a couple degrees just in a few seconds as we were waving that back and forth. As we continue to wave that back and forth, we're going to see that the temperature is going to continue to go down because when evaporation takes place again, it takes energy to do that, and it's going to cause the temperature to go down and decrease because that energy is going to transfer to the water, and then that's going to cause that water to change forms from liquid to gas. And as we keep going here, we can see that that temperature is now at least 5 degrees cooler than where we started, showing that, again, evaporation, it takes energy to change that liquid into a gas and for evaporation to take place. One of the next things we're going to look at is condensation. And as we're looking at condensation, we're going to start to talk about the dew point as well. So we're going to tie those two things together. One of the other things we had was a worksheet in class where we looked at the story with Ingrid and Christine. And we've seen that Ingrid and Christine were confused about the difference between condensation and evaporation, and they thought that sweating had to do with condensation. And as we went through this one, we could see that sweating doesn't have to do with condensation, but it actually has to do with evaporation. So with evaporation, when water gets put on your hands or anything like that, and you can wave them around, you'll feel that it will be cooler. That's because when water evaporates, it needs energy to evaporate, and those molecules are moving fast enough to help the liquid water escape and become a vapor. So as that energy transfers from your skin to the surrounding liquid, it helps that water evaporate, and that's why you feel cooler as you transfer energy away from your body to that liquid water. One of the next labs that we did in class was where we tried to calculate what the dew point is, and while we're trying to do that, we're looking to get condensation to form on the outside of one of the cups. So I'm speeding the video up here a little bit. What we did was we added a little bit of ice to some water and stirred it around with the thermometer. And you can see that the thermometer has already gone down quite a bit temperature-wise, starting off at somewhere around 18 or so degrees Celsius and now getting closer to like 5 degrees Celsius. So as we're waiting for condensation to form on the outside of the cup, that's going to be water in the air changing back to liquid water, and it's going to stick to the outside of that plastic cup. Once we get that to happen, we're going to then transfer back and forth between the different cups. And we'll keep doing that until we don't get any more dew forming. So as we're looking there, we're below 5 degrees. We could see a little bit of dew forming right in here. Since we're getting some dew to form, we don't need to cool the water off anymore, so we can get rid of the ice. And we'll transfer the water to a dry cup. Check and see if dew forms again. In this case, we went back and forth, and I had the students, as they were doing this, just keep track of what the temperature was each time they checked. And you can see again here we still got a little bit of dew to form. So since we keep getting dew to form, we keep transferring this back and forth. I'll speed this up a little bit. And we keep transferring this back and forth again. And that time we're taking a little pause there, so we start a little bit. So we're getting closer to about 5 degrees. And we check for dew forming again. And in this case, since we don't get any dew to form, we've calculated then that the dew point in the classroom is about 5 degrees Celsius. We also had a worksheet that went along with the dew point and what the importance of the dew point was. So we have some of the questions here. The dew point is monitored by meteorologists, and the importance of the dew point is the temperature at which saturation occurs in the air. Any additional drop in the temperature will cause the water vapor to condense as a liquid, forming dew, fog, or clouds. The dew point helps meteorologists predict when rain or fog or clouds is going to form. Under what conditions won't dew be able to form? Okay, dew is not going to be able to form when it's very, very dry, or if the humidity is very, very low. If there's a very, very cold temperature, that would also be a factor. And the dew is not going to form if the temperature doesn't reach the dew point. So if we can't cool the air off enough down to the dew point, then we won't get that water vapor to start to condense out. The other thing that's going to prevent dew from forming is wind. Question 3, when we get a dew forming on a surface and it's below freezing, we'd call that frost, or that dew is going to freeze on that surface. Question 4 is on here. People who wear glasses see condensation on their lenses when they walk from the outdoors and when it's cold outside into a warm house. Why does that happen? The glasses are cooler than the air in the house. The air in the house is going to transfer to the glasses, and it's going to transfer that energy. The reduced temperature of the air in the house is going to cause the water molecules or the water vapor to then condense and stick to the glasses, and that's why the glasses will get fogged up. And with the 5th question here, is the dew point always the same? The dew point changes depending on the humidity. The air has to be saturated before condensation can happen, so when there's less water vapor in the air is saturated at a lower temperature. And we can check that by taking the dew point on different days when it is different temperatures or under different conditions outside. One of the other things we did in class was read the article Dragon's Breath, where it talks about the dew point and water vapor in the air, and it kind of goes over a lot of the demonstrations and activities that we did in class. They had a couple questions at the end, and with those questions, asking about like what the relative humidity is, what is dew point, and some different questions there. Why does fog form on bathroom mirrors? What days would it be possible to get frozen Dragon's Breath? And if we go over here, we have the answers to those questions from the reading that we did in class. If you have any questions about anything that we went over on condensation and dew point and evaporation, feel free to stop by in class and ask.